Hi, my name is Dr. Ira Cohen. I'm the co-founder and chief data scientist of Anodot. And today I'm going to talk about the four main reasons why AI and ML projects fail and how to overcome them, or at least I'll try to show an example of of that. So, AI and ML are being pushed spread and wide throughout enterprises. 92% of enterprises are increasing their investment in it. Telcos are introducing systems which are AI-based all over the place and at very high rate. So is it working? Well, we see conflicting numbers coming out of various reports. So one report showed that 88% of AI use cases did not even go beyond the experimental stage. So they failed at the experimental stage. But we do see that companies that are early adopters of AI that did succeed in some of these projects are seeing up to 15% increase in profit margins than their industry average. So there's definitely a benefit to getting these projects working. The question is, what is making them fail? So let's talk about the four main reasons why these projects tend to fail in companies. The first reason is actually, I call it the hype reason. People want to solve every problem with machine learning and think that every problem is a good fit to be solved with machine learning. As a data scientist, as a machine learning practitioner and researcher for the past 20 years, I can tell you that if you can solve a problem without machine learning, solve it without machine learning. It's better. Machine learning introduces uncertainty and risk. And if it is solvable without it in a good enough way, and it's not a good fit for machine learning, then don't use it. The second thing that actually is probably the biggest problem for a lot of these projects is that really the requirements and the success criteria are never set correctly. So the data science team, the machine learning experts that try to implement it are not implementing the right thing, and it keeps changing on them. And a lot of the projects do not progress from research to even implementation because of these reasons. The third reason is that a lot of times, you want to have a big agenda around AI, then you buy a big platform for doing everything. And AI and machine learning is a new thing in the industry. It's been around in research for a long time, but the pace of changes are so fast that this is not the time to buy a platform that does everything for you. You can develop any type of machine learning on it. You want a best of breed solution, and because things are ever changing and still early days of machine learning and AI in industry. So there isn't really yet, a commoditization, a complete commoditization of it. So don't try to bite everything with one big project. The fourth reason is actually cultural resistance. People are afraid they'll lose their jobs. A lot of times the products or the solutions that use ML are designed by data scientists, and then the people supposed to use them are not data scientists, and they don't understand what they're seeing, and there is no good explanations. The UI is not good. The user experience is not designed for non-data scientists. Couple that with the fear of losing your job, and you get a lot of cultural resistance towards these tools. These are the four main reasons. Let's talk about one particular example in telcos of a machine learning project, and how do we actually go through making sure that it does not fail. And I'm going to talk about network monitoring in specifically. So the first question we have to ask, should we use machine learning for network monitoring? And the answer is a resounding yes, and we know it from experience. And let me show you how we went through solving these issues to make sure that whatever we generate for network monitoring is not a failure, does not cause a failure. So the first question you have to ask yourself, and very honestly, is this problem of network monitoring a good fit to be solved, to use AI and ML for it? As I said, if it's not a good fit, don't use it. Well, what's the state of today's network monitoring with existing tools? NOCs are getting billions of fault alarms per day. So they're overwhelmed by a lot of alerts coming from a lot of different systems. And billions is for the entire industry. Every company has a different number, but tens of thousands to millions is not far-fetched in terms of number of fault alarms per day from the existing systems with static thresholds and from various vendors. So lots of alerts. There's a problem of scale. A lot of false positives. All NOCs, all companies that we've talked to report have very high false positives rates from these static threshold rules or manual rules that they have to deal with and weed through. And there is also the problem of late detection. Despite all of these fault alarms, all of these false positives, a lot of times issues are detected by the end users themselves through down detectors or customers calling to complain. And that's the worst thing that you want. So you have late detection, a lot of errors, false positives, and a large volume because the environments are very complex. So basically, when I ask myself, can this problem be solved with AI and machine learning, I have to answer yes to one of three questions. Do we need better scale? The answer is yes. Do we need better accuracy? Yeah, we have a lot of false positives, so the answer is yes. Do we need better speed, detecting things faster? Yes. So machine learning, if you can answer yes to any one of these questions, you should start the project. If you can't answer yes to one of these questions, you should say no. So for network monitoring, it's a definite yes. Now comes the success criteria and how to derive the requirements from what you're building from those success criteria. And really in monitoring, in network monitoring, there are two main success criteria. You want to reduce the time to detect network issues to a minimum, and you want to reduce the mean time to repair. So, if you can reduce both of them, you get happier customers, you have less issues or very small issues that you fix very quickly, and everything's well. How do you achieve, what are the requirements on the AI-based monitoring? So the machine learning algorithms that you're going to design, what are the requirements based on these two success criteria? So for reducing time to detect, you want to use something you want to detect. How do you detect network issues? The main way with machine learning is using anomaly detection. So you need this anomaly detection to be very accurate. You don't want a lot of false positives. You want it to be accurate. And you want it to apply to all the performance metrics that you have, not just to a small subset. Why? Because if you apply it only to part of the data, it means that you're going to miss some issues when they start. And then your time to detect an issue is going to be longer because the customer is going to complain at some point because your system did not detect it. You need to be accurate because you want to reduce all those false positives that we mentioned. Now you want it also to be in near real-time detection. So real-time is milliseconds or microseconds. Here, 1 minute, 2 minutes is not a big deal usually. So it has to work at scale, accurately, and in near real-time. Now, what about reducing mean time to repair? So you detected that there is an issue on all your performance metrics. Now you want to have a way to fix them as quickly as possible. Here, you want to first be able to know what is related, all the related anomalies, and you want this to be an autonomous correlation of all the related anomalies and events. Because if you know everything that is happening, that's correlated to, that this incident has a lot of different anomalies contained within it, the time to understand why it happened is going to be much shorter. For that, you also want to be able to collect data and analyze the data. Your anomaly detection has to analyze data from multiple network sources, not just one. You have to break the silos. And lastly, you want to eventually achieve a system that automatically learns how to remediate incidents. So this is an example of how you take the success criteria and build correct requirements for your machine learning team that is going to build this, or the requirements that you're going to evaluate any product that you're going to use for network monitoring. Now let me illustrate and finish with an example. So this is how network monitoring looks like without AI ML. Basically, you get a lot of dots, and some of them are flagged as red, and you don't really know what's happening. But basically, your NOC is going by dot to understand why did I get this alert and fixing it. But you can't see the picture. Now, if you apply accurate anomaly detection on all of your data, you're going to get a picture like this. The amount of dots your NOC is going to have to look at, the amount of alarms is going to be reduced dramatically, but you still don't really know exactly what is happening here. You just see less alarms, but you don't know what the picture is. Now, if you couple that with correlation, you're going to see the picture. Because correlations basically is going to connect the dots and tell you all of these anomalies are related to each other, and this is how they look like. And now when I see this, I know what to do. I understand that the danger I'm in, how big or small it is, and I can start figuring out how do I remediate the problem so I don't get hit by this danger. So thank you for watching, and I hope this was a good learning experience. Thank you.